Good afternoon, class. We are looking at chapter 2, linear and absolute and quadratic functions. Here's section 2.3, modeling with linear functions. We have covered linear functions, graphs of linear functions, and now modeling with linear functions. The objectives are to build linear models from verbal descriptions, model a set of data with linear functions. Reminding you of what we have seen as far as linear functions are concerned. Slope, rise over run, delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The average rate of change of y with respect to x. Vertical line, VL for short, x equals a, is the equation. M, the slope is undefined, the x-intercept located at a comma 0. Horizontal lines, in general, they have the equation y equals b, the slope m is 0, and they have a y-intercept located at 0b. Two lines are considered parallel if they have equal slopes, m sub 1 equals m sub 2, but different y-intercepts, b sub 1 is not equal to b sub 2. Lines are considered perpendicular if the relationship between the two slopes is that they are negative reciprocal. M1 is negative 1 over M2, or M2 is negative 1 over M1, or M1, M2 is negative 1, their product. Lines have three formats. Standard form, AX plus BY equals C. In other words, X and Y are on the same side. If you solve for Y, it gives rise to slope-intercept form, Y equals MX plus B. And we have a point slope form of a line, Y minus Y1 equals M times X minus X sub 1. So those are the three formats, reminding you of that. Using the average rate of change to identify linear functions. Average rate of change is basically rise over run, the concept known as the slope. If we look at all of this and you have a curve, you pick two pairs, 2 points, and draw a line, it's a secant line. Average rate of change, or the difference quotient, DQ. Delta y over delta x is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So if you look at this one, we used x sub 1 and x sub 2. So that's the formula. This is called the average rate of change of y, or f of x, with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. These are all secant lines. Rise over run. Now, of course, if you call this x sub 1 and call this y sub 1, this one x sub 2 and y sub 2 is the good old slope that we know. It depends how you call that. So we have this format from here, this format in general. If you say this is A and this is B and f of B, you get to this one. If you keep it as x and f of x, you get to this one. X and f of x, A and f of A. And if you go with this last one, this distance is h, this is A plus h, it gives rise to this. All of them are the same. Average rate of change of y with respect to x. Rise over run, slope of a secant line, they are all the same. Modeling with linear functions, build linear models from verbal descriptions. Given a constant average rate of change, y equals f of x with respect to x, or the slope, a linear function can be used to model the relation between the variables y equals f of x equals mx plus b, where b is f of 0. The y-intercept. Here's example 1. As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height h in kilometers, assuming that a linear model is appropriate. So we are going to use T and H, and the order is H comma T, because T is a function of H. So I want to make sure we understand what's happening. Normally, we use X comma Y. X is the independent variable. Now, H comma T. Y in this format. T as a function of H, Y as a function of X. And so if the ground temperature is 20 degrees, that means the height is 0 and the temperature is 20, 0 comma 20. The height of 1 is 10, so 1 comma 10. So first and foremost, understand instead of X and Y, we're going to go with H and T. The ground temperature gives us the pair 0 comma 20. And the height of 1 kilometer gives us 1 comma 10 degrees Celsius. So we want to find the equation. So first we have to find the slope. Remember, slope is rise over run. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now we get t sub 2 minus t sub 1 over h sub 2 minus h sub 1. Again, I want you to see what we are familiar with and what we are going to need for this specific question. So 10 minus 20 over 1 minus 0. And that gives us negative 10 in the numerator, a positive 1 in the denominator, negative 10. Units of the numerator, change in temperature in degrees Celsius, over units of the denominator, change in the height in kilometers. So as far as the units are concerned, whatever units here over whatever units here. So it's very easy to figure it out. We use y equals mx plus b whenever b is known. 0 20 means instead of saying the y-intercept, the t-intercept is known. So we have m, which is negative 10, and instead of y, we are going to use t. So t equals m negative 10. Instead of x, we're going to go with h plus 20. T is minus 10h plus 20. T as a function of h. T is the dependent variable. H is the independent variable. And so we want to draw the graph of the function. What does the slope represent as far as the intercepts are concerned. We have B to be the y-intercept. So 20 is the t-intercept. That means 0, 20. So 0, 20, we have it. Also, if you set this one equal to 0, height becomes what? 2. When the height is 2, temperature is 0. So 2, 0. Normally we say this is the x-intercept for here, but for here we say h-intercept. And you can graph the 2 points. So you have a rectangular coordinate system, 0, 20 along the y-axis. In this case, we're going to say along the t-axis. 2, 0 along the x-axis. We're going to say the h-axis. Okay. Please understand the scales can be different. The scale along the h and t, they don't have to be the same. So t is minus 10h plus 20. And the reason this doesn't continue, because on this side, we are dealing with a negative height. So we can't. We are looking at the ground zero and up. Now, we know the slope was this, so negative 10 degrees Celsius per kilometer. What does that represent? This is the average rate of change of temperature with respect to the height. So those are the 2 points. Okay, those are the 2 points. The slope is m, or minus 10 degrees Celsius per kilometer. It represents the rate of change of temperature, the numerator, with respect to the height, the denominator. What is the temperature at a height of 2.5 kilometers? Here's the formula. Replace the h with 2.5. So negative 10 times 2.5 negative 25 plus 20 is negative 5 degrees Celsius. Monthly cost of driving a car depends on the number of miles driven. In April, the cost is $380, 480 miles driven. In May, the cost is $460, 800 miles driven. All right, so again, on April, cost is $380, 400 miles driven. In May, cost is $460, 800 miles driven. And we're going to express the cost C as a function of the distance D. First, x comma y changes to D comma C. Bear in mind, how do you figure this out? Cost as a function of D. D is the independent variable. Okay, that's how it works. Now let's look at the pairs. This one, first we put the D 480 and the cost is 380. This one, 800, comma 460. So we put the 2 pairs. Now, The slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In this case would be c sub 2 minus c sub 1 over d sub 2 minus d sub 1. So first we write the formula that we are familiar with. Then we extend it to the pair. And if we have a difficult time following that, you can do the following, everybody. Put x at top of d, y at top of c, and now this becomes easy to understand. So 460 minus 380 goes to the numerator, 800 minus 480 goes to the denominator. This is 80, this is 320. The answer is 1/4 or 0.25. Y minus y1 is equal to m times x minus x sub 1. So x and y gives you that. C and d gives you c minus c1 equals m times d minus d1. So you choose one of these two pairs. So c, for example, this one, c minus 460 is m, which is 1/4. X becomes d minus 800. So please look at this one, compare, and write this accordingly. Now, uh, 1/4 d minus 1/4 of 800 is 200. We add 460 and it becomes 260. So C is 1/4 of D plus 260. That is the linear formula. What is the cost of driving 1,500 miles per month? So that means replace the D with 1,500. You divide this number by 4 or 1/4 times 1,500 and you add to it 260. You get $635. And 75 plus 260. Draw the graph of the function. What does the slope represent? And all we have to do we can use those two pairs. We can use 0 to 60 as the c-intercept. And so this is just those two pairs that we have. Again, it's hard to show it. The numbers are fairly large. So you can use a scale of your choosing. The slope. What does the slope represent? This 1/4. The slope of 1/4 of a dollar represents the amount of increase in cost for every mile driven. For 1 mile, we have to add 1/4 of a dollar. For 2 miles, 2 times that. For 10 miles, 10 times that. What does the c-intercept represent? That's a fixed cost, everyone. no matter what. In other words, don't drive it at all. This would be the cost. The C-intercept represents the fixed cost of operation, $260, because there are payments involved, because you have fixed monthly costs such as insurance and car payments, as well as costs that increase as you drive, such as gasoline, oil, and tires, and the cost of this for each additional mile driven is a constant. So I hope it's clear to everybody. The cost C in dollars of a cellular phone plan is given by the function C of x is 0.3x plus 7, where x is the number of minutes used. What is the cost of the plan if you talk for 150 minutes? Well, the function is given, you simply replace the x with 150, that's all. So C of 150, that means 0.3 times 150 plus 7. Three times 15, 45. Please understand 101 decimal, they cancel each other. So pretty straightforward, everybody. $52. If the bill is 220 bucks, how many minutes were used? So the cost is replaced with 220, find X. That's the idea. So we subtract 7 from 220 and we divide by 0.3. Becomes 710 minutes. So if it costs 220 bucks, that means this much talk. What is the maximum number of minutes that can be used for $120? Replace the cost with 120. Again, subtract 7, divide by 0.3. Just like this one, subtract 7, divide by 0.3. Minus 7, divide by 0.3, which makes it 103. Now, it's important that first you show the answer with the decimal. 376.67. But what is the maximum number of minutes if we go with natural numbers, integers? You can't go beyond 376 minutes because if you said 370, this is not a matter of rounding. If you use 377 minutes, you have to pay a little bit more than 120. Since we are fixed at 120, then maximum is the whole part of the number 376 minutes. I hope everybody understands the reason. Example 4, book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate their assets using straight line depreciation so that the value of the asset declines by a fixed amount each year. The amount of the decline depends on the useful life that the company places on the asset. Suppose that a company just purchased a fleet of new cars for its sales forces at a cost of $28,000 per car. The company chooses to depreciate each vehicle using the straight line method over 7 years. This means that each car will depreciate by $28,000 over 7 or $4,000 per year. Write a linear function that expresses the book value V of each car as a function of its age X. Well, Y or f of X equals mx plus b. So because we're going to go with the value, we're going to change this to V of X. M is a 4,000, but it's depreciating, so it's negative 4,000. X plus B. How much did we purchase it in the first place? 28,000. This means if you replace the X with 7 over the course of 7 years, it will be worthless. $0. So one more time. F of X equals mx plus b. Instead of f of X, we are going to choose V of X because they are using V. M, we found this to be $4,000. This is the amount of depreciation. That means negative, minus 4,000x. How much was it in the first place? 20,000. 28,000. If you replace the x with 0, that shows how much the car was bought. So graph the linear function. The y-intercept, and now we're going to call it the v-intercept, is this amount, 0, 28,000. The x-intercept, if you set this equal to 0, 7 will give you 0. So 7, 0. So those are the two pairs, 0, 28,000. It's not the b-intercept now, it's the v-intercept. And of course, if you set this equal to 0, x becomes 7, that's the x-intercept. And you clearly can't use the same scale because this is 28,000. So we use different scales. This is 7, 0. And this is 0, 28,000. So again, I can't emphasize the fact that you don't have to use the same scale. What is the book value of V of each car after 3 years? So replace the X with 3. Negative 4 times 3, negative 12,000. Add 28,000, you get 16,000. So after 3 years, the car that was bought for $28,000 goes down in value, and it goes down to 16,000. Interpret the slope. By the way, I remind you that the v-intercept, it's the initial value. Okay, that's the interpretation of that. What is the interpretation of the slope? The slope is the average rate of change and is negative 4,000. So this means that for each additional year that passes, the book value of the car decreases by $4,000. When is the book value V of each car $8,000? Going back to this again, just like replacing the VB with whatever number that they gave us. So 8,000 equals minus 4,000x plus 28,000. So obviously, we are going to move this and make it negative 28,000, which becomes negative 20,000. You divide the negative 20,000 by negative 4,000, it takes 5 years. So in 5 years, it'll be worth $8,000 because 5 times 4, $20,000 comes off of this value. It devalues by that much. It depreciates by that much. Example 5, supply and demand. The quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of a product that consumers are willing to purchase at a given price. Suppose that the quantity supplied S and quantity demanded D of cellular telephones each month are given by the following functions where P is the price in dollars of the telephone. So S of P is 60p minus 900. D of P is minus 15p plus 2850. The equilibrium price of a product is defined as the price at which quantity supplied equals quantity demanded. That is, the equilibrium price is the price at which S of P equals D of P. Find the equilibrium price of cellular phones. What is the equilibrium quantity, the amount demanded or supplied at the equilibrium price? Ultimately, at the equilibrium price, okay, the companies and the consumers, they come to an agreement to make the deal happen. So we set them equal and we solve for P, which means this moves here, plus 15p becomes 75p. This moves here, plus 900 becomes 3750. Divide both sides by 75. P is 50, so the price is $50. How many units? Well, you put this into any of them. For example, if you put it into S of P, 60 times 50, 3,000 minus 900 is 2,100. Now, before we move on, it's important to know that you should really put it into this, and the two must be identical. Otherwise, we've made a mistake somehow here. So whether you put this into this one or this one makes no difference, but I highly recommend you do both, and they become identical. Minus 15 times 50 plus 2850 should be 2,100 as well. And it is, because it's negative 750. With that, it adds up. What does it mean? The equilibrium point has coordinates $50, 2,100 phones. Okay, So at that point, the demand is met, the correct pricing, the correct number of phones are being sold. Determine the prices for which quantity supplied is greater than quantity demanded. That is solved for S of P larger than D of P. So the supply has this formula, the demand has this formula, so S of P, this one larger than this one. And ultimately we get to this one, but larger than the same. We see it's identical to this one instead of equality is greater than. So we get to the same answer, 75p. I can show you that one. So this one goes this way, becomes plus 15p. This goes this way, becomes plus 900. And 75p larger than 3750, divide, and p is larger than 50. In other words, think about it. If the price is larger than 50, so the price of 50, the deal takes place. If the price is larger than 50, it's good for the company, it's good for the suppliers, they love that. And so if the price is larger than 50, that's where they want to produce more. If the company charges more than 50 bucks per phone, then quantity supplied will exceed quantity demanded. In this case, the company will have excess phones in inventory, because if it goes higher, perhaps the deal will break. Some people still buy, but some don't. So we want to graph this. S is S of P, D is D of P, and label the equilibrium price. S of P is this formula. This is from the previous page. 60p minus 900. D of P is minus 15p plus 2850. And if you set this equal to 0, if you set this equal to 0, then P becomes 15. So you have 15, 0, and this was the equilibrium point or price. We have that, which works for both. And this one, if P is 0, you get 2850, and this works for both of them. We could do the same thing here. P is 0, this is negative 900, but we don't want to go to, we just, in the actuality, we live in the first quadrant, okay? Because both must be positive, okay? The price and the demand, that's why. So if we graph this, this is the equilibrium point with coordinates 50, 20, 100. This is 0, 28, 50. Okay, somewhere we have the 15, 0, and all you have to do, connect these two, connect these two. And so what you're looking at, these two gives you S or S of P. These two gives you D or D of P. This is the equilibrium point. This is where the trade takes place.